Hello, everybody. My name is Jordan. Thank you so much for joining us this morning. If you don't know, I work with the Lower Blackwood Landcare Group, and we're based down here in the beautiful southwest of Australia. We are a not-for-profit independent landcare organisation working to support sustainable agriculture, healthy environments, and thriving waterways across the Lower Blackwood catchment. If you'd like to learn a little bit more about what we do, you can check us out at lowerblackwood.com.au. Today's webinar is part of a collaborative project we're running with RegenWA called Make Your Hectare Count, and is supported by funding from WA Government's state NRM program. Before we get underway, I'd like to moment to acknowledge the Lower Blackwood catchment, and the work that we do lies within Wandandi Pimpleman Budja, whose streams and tributaries flow together to the Gorbal or Blackwood River. We recognise and deeply respect the Wandandi and Pimpleman people as the traditional custodians of this country, and we honour their enduring connection to the land, the water, and the community. Little bit of housekeeping before we start. As you might notice, you can hear us, but you can't speak. That is intentional, just to make things run super smoothly, but you can totally ask questions in the little chat box down the side. It should be on your right-hand side down the bottom. It'll say type your message. And if you need any help, you can just message or call me and I can help you out. We are also recording the session, so if you miss out on anything, I'll have to duck out early. That's totally fine. I'll upload this and send a link out to everybody next week. Now on to the reason you're actually here. I'm delighted to welcome Kevin Elmy from Cover Crops Canada. I was going to say Australia, that's not the right one. Kevin is a third-generation farmer turned educator near the Saltcoats in Saskatchewan, who spent over 2 decades pioneering soil health and cover cropping systems in his own property. Since adopting first soil health principles in 2000 and introducing cover crops in 2009, Kevin and his family have successfully reduced synthetic inputs while maintaining strong yields. These days, Kevin works all around the world as a regenerative agriculture coach and speaker. He has recently just been in Ukraine and has hosted Ukrainians over in Canada. He's helping graziers and growers and advisors better to understand what's happening beneath the surface, how soil biology, cover crops, and plant microbe interactions and farming systems all work together to build resilience, vitality, and productivity. So without further ado, please welcome Kevin Elmy.
Well, thank you very much. Thanks for inviting me out to do this webinar, and if anybody enjoys it, next February we'll be out there live, and we'll be putting on some meetings. So stay tuned for some information on that. This is the first time I've used the Click Meeting program, so hopefully I can figure this out quick. So we're going to go get the dirt on soil health, and we're going to talk about the strong pastures and healthy stock, and it's all all interrelated as we go through. And the fun thing with this is the principles that we talk about that I've learned. They work in Canada, they work in the United States, they work in Australia, they work in, I would say, Ukraine, but there's not a lot of grazing over there that we saw. So, but the fundamentals are all the same, and how we're going to do it is going to really have that local flavor. So going into the presentation. There we go. So what is multi-species farming? How do you do it? Where do you start? What is correct? And that's going to be one of the catches for most people. How much does it cost? What do I need to know? Is anybody else doing this? Where do I find help? And one of the things when I spent my year in WA, there's some great people doing some great things. So this is a picture from Blythe Callan's property. Stuff she was doing is absolutely amazing. The stuff that she would learn to adapt, it was spot on. And the biggest thing with it is, as she was going along, she had a good connection of people and had help. One of the things I found was there was a strong need for more support. RegenWA is doing a great job. There's great people out there, but it's to get out there and kind of bang the drum of not just talking theory, but actually coming up with potential solutions to the problems or strategies, coming up with the strategies that we can figure out to make it work. And the I guess for most people, the problem they have, especially going from, say, a more conventional system, is we have to be systems thinking. We have to be thinking as a whole. We just can't say, oh, we're going to do this and that's going to change everything. We have to look at our system. And the scary thing is when most people, when we're doing our presentations, they say, okay, what is the recipe? So to grow a 2-ton wheat crop, this is the recipe you do it. This is when you seed it. This is when you spray it. This is when it comes to regenerative principles and management. Each each property is going to have their own unique prescription, and I'll use prescription very loosely, but it's basically as we go through what we want to do is figure out that system for that piece, so that when we have that those gutless white sands, okay, so how do we manage those as compared to if we do have some heavier textures, some clays, how do we manage that? Along the coast, when we get a little more rain, how do we manage that versus having something out near say Lake King, where we're dealing with salinity, we're dealing with hot, dry. How do we do that? And so the principles are going to be the same. It's the how we do it is going to be changing. And then as we start developing this, all of a sudden we'll identify that within that one paddock, maybe there's another management zone that we're going to have to break that into. The other thing is that speed of change. So everybody they don't mind change as long as it's exactly as it was before. But if it was as it was before, we're still going to have the same issues, the same problems that we have. So then, okay, so how long does it take to do that change from a conventional mindset to regenerative? And that's all going to depend on your economics, your labor, your equipment, the knowledge, the education that you provide yourself, any partnerships, and then of course your climate, which is going to be the big driver of anything when we're dealing with agriculture. We're always looking at the sky. And so the first thing that we really need to do is get into goal setting. And so this chart over here, it's kind of comical because it doesn't matter what source or what system you're looking at. We usually get into the this type of curve where when we first, it's kind of what is this, and then you start a little bit into this. Oh, this is easy, so I know everything. And then you actually start doing it, and it's, whoa, this is a little more complicated than I thought. And then you start getting a little more depressed of, I'll never understand this. And this is where most people stop and they go back to the old system. And so what I want to do is offer my experience to take you to that next one where it's starting to make more sense. And then once you understand that it's making sense, that next one is, trust me, it's complicated. And it isn't from the point of complicated of being overly complex. It's just a lot of the things that are happening out there we really don't know. But we'll go through some of the principles on how we can go through and manage to get through that and move that needle forward. So when we're setting these goals, we need to know where you are and where we're going. So what issues are you facing? And the other thing is when we go out and we have this new management system. Okay, so here's the goals. Well, we need to have a kind of a goal point to see if what we did was successful. And it isn't necessarily yield that we're looking for. We're looking for issues. We need to find issues in our production system, and we really want to look at differentiating between the cause versus symptom. And that's one of the really important things when we start looking at these problems. So by definition, when on Google, just what is a symptom? It's evidence of a disorder. A cause, by a Google definition, is a reason that gives rise to action. And it's really important to differentiate between those two because of the fact that it's going to give you different potential results of whether it's going to fix it or it's going to be reoccurring. So what we need to do is treat the cause and not the symptom. If the symptom reappears, that means we haven't identified the actual cause. And so the joke that I use is, I went to the doctor and I said, doctor, it hurts when I touch my head, and doctor, it hurts when I touch my ribs, and it hurts when I touch my knee. And instead of the doctor going and getting MRIs and doing blood tests and doing, all these other tests that cost money, doctor looked at my finger and said, you have a broken finger. And that, cuts the chase in a hurry. So it fixed the finger, and then everything else, all the other symptoms disappear. The problem is when we have some of these issues in agriculture, there's going to be like an onion where we have these multiple causes. We're going to have these layers. So we have to kind of peel off these layers to actually find the problem. And this is where, and maybe it's timely, I just saw the video in WA when they're talking about compaction and deep ripping, and once again, it's, in my mind, that's just treating the symptom, not the actual cause. So when we look at compaction, the number of things that bring forward to the some of the causes of compaction is, number one, oversupplying nitrogen to the system. One is excessive tillage, and so under graziers, hopefully you're not doing excessive tillage, but the lack of plant growth, having shallow roots, having any field work when it's wet. And when I'm saying field work, is just not with a tractor. This is caused with the livestock also. Too large of equipment, and not enough tires underneath the load that you're carrying through the paddock. And those are the things that those are the things we have to be looking at. And which one of these are we doing, or is there multiple things that we are doing or not doing to address that problem? There we go. So the goal setting, that has to be the first step. So when you're looking at your system, what do you want to change? What are the issues? What limitations do you have, and to solve these issues? What tools do you have access to? And the nice thing about WA is, there's groups that do have equipment for rental. And so if we can go out and we can borrow or rent something to turn things around, great. What kind of budget do you have? Once again, it's all going back to economics. If it's not going to make sense to do, then why are we doing it? And then what kind of time frame do we have to address this? And when I start looking at any business in the world, when we have a problem and we're looking for solutions, we have basically three options for solutions. And they're going to be good, fast, and cheap, and we get to pick two of them. And when we go through, and if it's going to be good and fast, well, maybe it's not going to be all that cheap. So it's always that trade-off on how we're going to be doing that. And when we start doing this goal setting as a farmer, I hate setting goals. So what I've done on my website, thecovercrops.ca, I have a cover crop needs assessment sheet. And this is just a cheat sheet that this way it's going to help you set some goals, so that if you email or we're on WhatsApp or we're talking, at least we have some basically, you're going to have the information that the questions I'm going to be asking. And this is really going to start moving things forward, so that this way, especially when you have them written down at the end of the season, you're going to be able to say, yes, it was successful, or no, it wasn't, or geez, that was, maybe I misidentified what the actual problems and the causes are. So this way it helps you break that down. So the soil biology, this is one of the things that, and once again, you're blessed that you have some great resources out there, like Ellen Walker, like the great resource. This picture is actually from a soil sample that I grabbed when I was in Serpentine, and sent it back to a lab in Alberta, Canada, and she said that was the biggest water bear she's ever seen in her life, and she's been working soil biology for for a very long time. So got some great stuff when I was over there. And the biology there, they have the same functional groups you do there as we do here, and it's just a little, little different function of the species, that the actual species that they have that have been adapted to your conditions, but they act the same way in the soil. And so if you've been into the regen world, you've seen this soil food web diagram. It looks very intimidating with all the arrows in there, but this is the whole thing of when we start looking at ecosystems. This is probably an ecosystem on top of an ecosystem, and this is only part of it. Never mind the fact that it's going to be interacting with other plants above ground and the rest of the soil biology. And once again, this is a simplified overview. What we know and what we don't know. Every year we're learning something new about the whole system to tweak some of the details, but in the big picture, this is how it works. So we have our primary level predator producers in the soil. So your bacteria and the fungi, and they're going to feed off your plant materials, your animal waste, your dead animals. They're going to be breaking down tissue to make the nutrients more available. Then your secondaries, or your primary predators, your protozoa, your amoebas, your nematodes, they're in there, and they're going to be feeding on the bacteria and the fungi. If you don't have those, we're not having nutrient cycling. We're just going to have the nutrient tie-up. Then we have our larger predators, and that just cycles. As it cycles, we're getting soil function, we're getting plant growth, we're getting animal performance of our grazing animals across, and the system works. The problem is when we start having compaction, when we have not enough plant diversity to get that bacteria and the fungi growing and being functioning in the soil, when we don't have the soil structure, so we don't have those predators, those secondary level predators in there. This is when things start falling apart. We have nutrient deficiencies. We have those problems in production, and so then we try relying on synthetics, which then breaks the relationship between the plant and the soil biology, and we just get deeper and deeper into trouble, and the animals suffer, we suffer, and we rely more and more on chemicals. So the soil biology, functioning soils do not require much support. And when we add that chemistry, it takes the jobs away from that soil biology. It breaks those bonds that have been, developed over thousands of years. And so we start getting problems. And when we start adding diversity to the soil, when we start adding different plants, managing them differently, we get some good things happening. And so one of the things when I was in New South Wales, we did a 2-day webinar in class workshop, and one of the host farms, they gave me this picture of a trial they did. And what they did is they seeded oats across this paddock that they were going to be grazing, and it was one of those dry years. So they went in half the field and they put some MAP in with the oats on the left, and on the right they went in with a compost extract. They used some vermicast, some kelp, a lot of biological products, and this is what the plants look like. And of course, it was a dry winter, so that this way, when they went in to graze the oats, they grazed the oats on the left one time and they died. The ones with the biological system had resilience, and that resilience allowed that oat to regrow 3 times and get grazings out of. So it may look a little slow up the start, and once again, with some of our soils that we're dealing with, one of the things that I highly recommend is going out and doing a full digestion of that soil, and they call it a mineralogical test, to see what nutrients we have in that soil. And so if it has been eroded, if it has been just abused in the past and those nutrients are truly gone, well, let's see what we have. And in a lot of cases, what happens is the soil, because the biology isn't active, we're not getting the the true cycling of the soil, we're not getting that communication from the plant to soil biology, then we start having those problems of nutrient deficiencies. So soil ratios, everybody's, when we start looking at the measuring, where are we in our soil health, our how much nutrients do we have, where are we going? Some of the things that I start looking at is the balance. So looking at the Albrecht method of nutrient balancing, real good way of making sure that we're keeping the pre-nutrients that we do add in balance with what's in the soil, and not throwing some chemical imbalances in there. I look at the carbon to nitrogen ratio in our soils and the plants that we're growing above it. And then in the soil, I'm looking at the fungal to bacteria ratio of what's happening in that soil. And so we're going to be looking at the active and the total, and then the average across the paddock across the year. Our soil texture we cannot change. So if we have white gutless sand, we have white gutless sand. I know there's projects where there's producers going out and they're getting some heavy equipment and taking the sand off the top and getting down to the clay, getting the clay, putting the sand back and putting the clay on top. And it's I would say, I don't know if there's any more expensive way of doing it, but that's the strategy some are doing, and it will be a relatively short-term fix. So organic, we can change, and we can change that fairly dramatically, really quickly. So by looking at all of these things, what can we change? It's going to be our management and start building this soil organic matter in our soils. So the Albrecht method of nutrient balancing, once again, start with a mineralogical test, find out what our total amount of these nutrients are in the soil. How deep do you want to go? That's your prerogative. I know Dr. Dwayne Beck at the Dakota Farms in South Dakota in the United States, he went down 4 feet, so 1.3 meters, and he found out how much in particular phosphate was in his soils. And so in the top 1.3 meters, it was showing that he had over 7,000 pounds of phosphate in his soil, but his soil tests in the top 15 centimeters was showing 4 parts per million. So it's interesting from the standpoint of doing that balance sheet to see exactly what is potential in our soils, where it's located in the soil. So do we need more tap roots in the soil? Do we just need more biology to get it freed up? And then doing that chemical extraction at a traditional soil test that once again gives you an idea that it's in our soils we're showing that we have 3,000 parts per million in the soil, but a soil test extraction shows that we only have 10 parts per million. So how do we increase that availability? And to go in and throwing on a whole bunch of excess nutrients all at one time, there's a great little chart I didn't include on here called the Mulder cycle, and it shows how different nutrients, when we add it, how it interacts with other things that we are adding. And one of the things that really messes up soil chemistry quickly is adding free calcium. And it really binds up, especially with the phosphate in the soil. And for the example of that, if you have a cow that dies and you bury it, and 10 years later you dig it up, and what do you find? You find bones and teeth, which is calcium phosphate. So it's watching how to address those nutritional deficiencies and keep things rolling. And once again, Dr. Elaine Ingham, she says that when we have plant nutrient deficiencies, it's due to microbial deficiencies in the soils, assuming that there is some nutrition in the soil that hasn't been blown away. So it's that carbon to nitrogen ratio. It's something where it gives you a really quick indication where your soils are at and what that soils are craving. So in this picture, there's two soil profiles that I dug up, and they were about 10 meters apart. So the one who's on the left It's from Saskatchewan. It was an organic farm, highly tilled. There's follow periods in there where there's nothing growing. And the one on the right was from the fence line, where so in the field there was, well, in the kind of in the background you can see there were some thistles in there that were 5 centimeters tall. They weren't very happy. There was a lot of weeds in there. It was dry. There was cracks in the soil because it was a high clay content. And yet 10 meters over in the fence line, that soil was rich black. It would look like the good chocolate cake. The grasses were chest high on me, and this is 10 meters apart, and it just reflects the management. So on the left, where it's hard, it's dry, that is a low carbon to nitrogen ratio soil, so it's carbon hungry. It needs some big carbon injections to get going. And if you don't do that and get the biology going, then you're going to need a lot of synthetics, and it's going to be hard soils. You're going to have weeds. There's going to be a lot of production issues. The one on the right, where we have a what I would call a good carbon to nitrogen ratio, it's going to be functioning. It's going to be clicking on all cylinders. If we get something that has a bunch of dead carbon in there, so we're going to have lots of plant material that's identifiable, whether it's wood, whether it's grass, then your C to N ratio starts getting above 14 to 1. Any nutrients, especially nitrogen, that gets applied to it is going to balance that carbon to nitrogen ratio, and you're not going to get any yield benefit out of it. And so these are the fields that when we go in and we have this high C to N ratio, we start adding nitrogen to it and it doesn't respond. That's the reason why. So these tired paddocks that we have, and this is I'm picking on the neighbor of mine in eastern Saskatchewan. This is what his putting green / pasture looked like. The cows were always roaming and looking for something to eat. Very sod bound. The carbon to nitrogen ratio is probably in that 16 or 18 to 1. Very low productivity. Very low bacterial activity in the soil, and that bacteria activity is really important from the standpoint of cycling nutrients. You have those woody weeds that are in there, and so that's another indication of where we are in that fungal to bacteria ratio that we're going to be getting to right away. It's a very low energy system of producing any grass or any kilos of meat off of a paddock like this. And what it really needs is lots of sugar, lots of photosynthate. We need more carbon in the soil. We need to get the bacteria functioning in those soils to get the production back. So that plant residue on top is another carbon to nitrogen ratio that I look at, and the quick rule of thumb is that C to N ratio is going to determine how quickly that residue is going to rot and those nutrients being released, just like a rumen. A narrow C to N ratio, that means it's going to be a fast rot and quick release of those nutrients. And what that means is those in the picture, the green plants growing, those are going to have a narrow C to N ratio. When we have a wider C to N ratio, so that's that straw in the paddock, it's going to be slowing down the rot. It's going to create that soil armor, but on the flip side, it's going to tie up those nutrients. And so we want to have a little bit of both in that. And once again, think of this as your rumen, because the soil and the rumen function the same way. And to have just one or the other doesn't work. We need to have both. So those lower carbon to nitrogen ratio things that we were looking at are going to be your green plants. It's going to be vegetative plants, higher protein plants, because carbon to nitrogen, something with a little higher nitrogen, is going to bring that ratio down. Things that are going to be wide C to N ratio, so it's going to be your straw things, material. It's going to be your mature plants. Those are going to be the quick rundown between what we're going to be looking for. And we can really tell when we start looking at the manure, and I apologize for the snow unless I've been following the weather down down in the southwest to see what it's been like, but right now it's I think the high is around +2 here I'm just north of Calgary, Alberta. This picture was from a few years ago, but this is what we want to be looking at when we look at the manure. That manure will then tell us what kind of feedstock that those animals are eating, that carbon nitrogen ratio. So when we feed both the green and the brown material to the soil and the rumen, we get proper function. When we have too much, too high of that carbon nitrogen ratio, those soils need more and more inputs to be functioning, and it's going to be, the manure is going to look like the top, very blocky type of manure. It's not going to be very very lifelike for the soil, for adding life. When we have too low of carbon nitrogen ratio, now we're going to have runny manure. We're going to have the soil is going to blow more. There's going to be more compaction. The rumen isn't functioning properly. So in both of those, the picture on the top and if you have runny manure, the rumen is not functioning. What we want, if for beef anyways, is to have a nice round patty. On the outside of the patty should be 3 to 5 centimeters thick, and in the middle should be between 1 and 2. So when we start looking at the manure, we can really tell how that rumen is functioning. And when the rumen's functioning properly, and the animals are eating what they should and they could, then we know that most likely that soil is being fed properly also. So checking manure is one of the things when we're going through our feed management, is what we need to be looking at. And when I was at a paddock walk, can't remember where we were, but we were in down south of Perth. We just got out to the paddock. It was just starting into the rainy season, and the producer was unrolling some silage bales, and I was looking at the manure, and it was just running out of them. And I asked the question of why aren't you putting some straw bales out there to slow down the digestion? And it came back with why. So we really need to be looking at the manure and creating good manure, and that means that we're producing better animals, healthier animals. When we're looking at the fungal to bacterial ratio in the soil, it's really important because different plant types need different microbial populations. Some plants need more bacterial dominated soils, and others need more fungal dominated soils. And if that ratio is not right, the plant will struggle. And in a lot of cases, especially if we're dealing with very bacterial dominant soils with low fungal populations, this is where weeds grow. Those plants that we don't want to grow will be taking over. So we really need to understand what plants we're growing and what conditions those plants like. And it kind of relates back to this fungal to bacteria ratio. So this is from the United States, but once again, it is true in every place that I've been and people I've talked to. So that when we go through and we start looking at, at these early successional soils, we're going to be, we'll skip, so the F to B, that's your fungal to bacteria ratio. And this ratio is in the kilos per hectare of the fungi to kilos per hectare of bacteria. So we can get a true comparison of where we're at. And the problem that most researchers hate about this theory is that if we feed the soil with something that promotes bacteria populations can increase tenfold in 4 days. So very responsive, and then they can crash really quick. So what we're looking at is kind of the season-long, year-long average of what is happening in your soils that will give you a quick average of that fungal bacteria ratio. So when we are in that fungal bacteria ratio of 0.1 to 0.3, this is where we grow weeds, and this is where Patterson curse, Cape weed, wild oats, those type of weeds grow. When you do a soil test, you'll have a high nitrate content in your soil, and you'll have lack of oxygen, which also is known as compaction. As we start building our fungal bacteria ratio and we get over that 0.3, this is where we start getting our grasses, our perennial grasses to establish. And I'm not familiar with enough of the WA forages, forbs, but you'll most likely be seeing as we start managing our soils and our paddocks, we'll start seeing some native species start showing up. And they usually start showing up when your fungal bacteria ratio starts getting over 0.6 to get into that 0.8. And when we have those native grasses growing, they like being, in a lot of cases, at 1-to-1 fungal bacteria ratio. But the problem is when we start getting over and we start getting those woody plant invasiveness, we start getting those shrubs, we start getting bushes, that's an indication that we have now crossed that line and gone too far. And so in agriculture, when we start talking about perennial forages, what we want to do is try and be somewhere between that 1-to-1 and even 0.5. We want to kind of manage it in there. And the way we do that is managing our plant growth, managing our grazing, and stimulating the system. And so as we manage, we'll move that back and forth. So there's going to be things that as we promote more bacteria, we may slide back. When we get more fungi, we can move it forward. And when we start doing tillage, once again, it isn't something that this theory only works in Canada. This is right from Blythe's farm at Runnymede. They had a soil key come in and found it astounding of how the soil having, even though once again we talk about zero till and we talk to build soil health, but when we have these fields that have they've lost the bacterial function in their soil, how going in and having that disturbance is hugely beneficial. So having that little bit of disturbance, adding that synthetic input, in some cases can work. But when you add too much, then we start going the wrong way. Having those non-mycorrhizal plants growing, having the good grazing management can decrease the fungal bacteria ratio positively. Basically, all of those will damage fungi and promote more bacteria. Whereas when we start going into zero till or surgical type of tillage, having those living roots, using mycorrhizal friendly plants, using good grazing management to increase our fungal bacteria ratio. And so what Blythe did in this paddock is with the soil key, she went in and basically it's a big rototiller on like about 40 centimeter spacing. And so it'll go in, it'll highly disturb a strip where, as Christine Jones says, if you're going to do tillage, replace some of the carbon really quick. And so what she did is she seeded some oats and some other species in that green strip there. And you can see exactly when you look at this picture where those tines went, that soil is darker. And when you do that and you have that plant growing, if you just did the tillage and disturbance without having those seeds there, it wouldn't look any different. But because she went in and did disturbance, seeded a cover crop in there, had those fresh root exudates in there, it was amazing how that soil was changing. And so to go in and have these specialized equipment and management, how we can really start turning around that soil. Because when you see that black strip where the disturbance was, it is significantly darker than where that disturbance wasn't. So it was an indication that was a really good management move on her behalf. So as we have these perennial forages and these forage stands become older, what happens is these mature plants, less and less root exudates get released out of them, and that decreases the amount of bacteria population that is being supported around those plants. Your nutrient cycle starts slowing down and your productivity starts dropping. And one of the rules of nature is these systems always want to gravitate to the lowest energy state under constant management. This way, it just conserves the energy, it reduces risks from the plants, and status quo. So what we'll see is when we seed down a perennial forage stand, the first 4 to 5 years we'll get some really good production under the same management. Then all of a sudden it starts dropping off. And this is where that grazing management and some of the speakers that are lined up to be coming in to do presentations on grazing, fantastic. You have some really good names in there, and I'll be forwarding along some other names of some other excellent graziers that do some education to the group to add more voices to give more ideas. So with these perennial stands, in order to keep them productive for a longer period of time, we need to have more of a holistic management approach. And this is where this adaptive multi-paddock grazing comes in. And what we're basically doing is changing the focus from having the animals grazing the grass to having the grass being managed by the livestock. And we're going to be able to manage that. So it isn't taking it right down to the roots. It is managing the grass so that this way we're giving it enough of a shock in order to get more root exudates, keep that stand really healthy and productive. And part of it is number one, we're going to be going in, we're going to be trampling. We have to be able to accept that we don't want to eat all of the grass. We want to trample it, and I understand there is the fire concerns about that, and we can address some of that in later discussions by going in and grazing a little harder right before the fire season, or making sure, like what Colin Seiss does, is having some summer actives growing out there, which is green, which doesn't really want to burn very well. So we want to do some trampling. We want to feed those soil microbes. We want to create that soil armor. We want to store as much water as we can, because when the tap turns off and we start not getting the rains anymore, we want to store as much water in that soil as we can, which once again is going to help with a fire. So when we have this adaptive multi-paddock grazing, and we're using the animals as a tool to manage the grass, now we have production system that starts looking more like this. So it doesn't start tailing off. We still have that early curve going up as the plants establish, but it's going to be something that as we go through it, we're going to maintain our production for a longer period of time. And once again, we get into a drought, we start getting more inland, it's going to be more of a risk. There's places in Western Canada that I work with that through the whole growing season, this is 12 months, they'll be dealing with 30 millimeters of precipitation throughout the whole year. And it is a huge challenge to get things going. But when we start dealing with areas with rain, sporadic rain, we have to be able to get those plants established and growing when we have that moisture available, and understanding the climatic cycles that we do work with. So our soil health principles that we go through, it's like I said, they're principles. They're how we actually implement them in different parts of the world are going to be differently, but the 5 that I work with is: number 1, keeping a plant in the vegetative stage for as many days as possible. Number 2, increasing functional plant diversity. Number 3, reducing the amount of tillage, and as a grazier, that's be able to be fairly easy on that. Number 4 is reducing reliance on synthetic inputs, and number 5 is properly incorporating livestock. So the reason why we want that vegetative plant, it is really important because 80% of the carbon captured through photosynthesis of a vegetative plant is going to be released as a root exudate. Once you see that stem, that number is going to drop off dramatically. When that drops off dramatically, now we're not feeding our soil. Having that plant continue to grow is going to build mycorrhizae fungi. It's going to absorb excess soil nitrates to create more nitrogen complex compounds, which now does not trigger any weeds, and it plays catch and release with the nutrients in our soil. It also creates a micro water cycle. So as those leaves cool off in the evening, the moisture from the air will condense on that leaf. When that leaf, it decides whether it needs that moisture. So if that plant is dry, it will soak it up, and then it will release it as a root exudate. And so when I was in Ukraine, you can see that black circle around that root in the middle of the picture. That is from a little shower that went through it was a corn plant, maize, and that corn plant funneled all that moisture down into the stem. The moisture followed the stem down and followed the roots into the soil to hydrate the soil. That was the first time I ever saw a picture. I was able to take a picture like this, so it was really, really interesting from my soil geek standpoint. A vegetative plant is going to have a higher root to shoot ratio, so that means you're going to have bigger roots than above. So it's going to help that plant material on the top is going to help cool that soil surface. It's going to use more moisture, soil moisture, which is going to reduce your evaporation, which is going to reduce the amount of salinization that we have. It's going to that increased transpiration is going to build soil aggregates, which is going to allow our soils to hold more moisture for a longer period of time. So when we have these non-wetting soils, when we have sandy soil, building that organic matter is really important in these soils. And having that vegetative plant at the end of the season before everything goes dormant is important, because now those root exudates are going to help to put a waterproof shield around our soil aggregates, so that when we get plants growing later in the season, it's going to, when they start waking up, those soil aggregates aren't just going to fall apart. They're going to have that I call it winterproofing, but in this case, it's going to be that the weatherproofing, so that this way they won't want to fall apart. So it's really important from that standpoint. The soil aggregate stability is really important for building soil health, to get this get the better use of soil water, to get the water infiltration, get the fungi growing, just make the system work. When we start talking about increasing functional plant groups, I work with 5. One is grasses, legumes, brassica, non-brassica broadleaf, and forbs. Within those, we have summer and winter active species, and within those, we have annual, biennial, and perennial plants that we can be choosing from. And when we start doing these mixes, I want to see as many of those as possible. Once again, this is from Blythe's farm. Reduce tillage. There's time and place for tillage. So when something sods up, we need to get some air in it. But how little can we do to get the job to work? And once again, so this is where the goals are: using that surgical tillage and then adding that carbon back in as we're doing that carbon pass. Doing it as shallow as possible, so we're not destroying the whole soil profile, but still remaining, have that soil armor remaining on that soil surface. Reducing the use of synthetics. Once again, as graziers, the fungicides, I don't know if there's anybody using any fungicides on grasses. If you are, we need to have a chat about that. Insecticides, yeah, I know that bugs do come in, but it's another indication. Once we get our Brix level up in our plants, bugs disappear. And one of the problems that when we start adding fertilizer is it reduces our root exudates, it reduces our microbial function, and our Brix level in our plants drop. When that drops, animal performance isn't there. We're going to get more disease. We're going to have less production. We need to find biological systems to replace those additives when we're doing this management. So the fertilizer, by adding any nitrogen, at best you're going to use 50% of what you apply. Synthetic phosphate, at best 15%. So, not really efficient ways of getting things down. The preferred path of nutrient uptake by plants is called rhizophagy, which was first identified in University of Queensland in 2010. They've known of it since the 1950s, but we just keep ignoring it because the input world, they can't make money off of it. Dr. James White estimates that 85% of the nutrient uptake by the plant should be taken up this way. And the way that rhizophagy works basically is as the root is pushing through the soil, as the root pushes forward, the root cap thins, microbes then pass through into the root, the cell wall of the plant, it passes through the cell wall, gets into the cell, and the cell will then strip the cell wall off of the microbe. It'll digest the cytoplasm of that microbe, eating the nutrients in it, and it will then start cycling that nucleus inside that cell wall, replicating it. And once there's enough of those nuclei of that bacteria in there, or whatever microbe it ate, it'll then spit it back out in front of the root cap, in front of the root tip, and it'll give it a signal to get stimulate that microbe to then reform a cell wall and the rest of the insides of that microbe to continue doing the microbe thing in the soil. Guess what? That root will then move ahead, capture that microbe to then get the nutrients out of it again and spit it back out. So it's a really interesting view of how nutrient uptake in plants will occur. And once again, fertilizer, well, it's more efficient, more predictable than working with this system. But once again, the fertilizer replaces the microbial role in the soil. And every time you add fertilizer, it's going to reduce your drought tolerance. It's going to reduce your plant bricks, which means the cows or sheep are going to be less likely to want to go eat it. And then when you add that nitrogen we over apply, or whether it's nitrogen or manure, it is going to create compaction. It's going to, with that lower bricks, create more disease and more insect attacks. So the way you get around it is we need to get more legumes in our mixes. We need to get the free living nitrogen fixers up and going, and this is where using some compost extracts is a great way to get them going. Get those with the mycorrhizae fungi. We get them going and productive. It's going to be sourcing a lot of phosphate and the micronutrients for our plants. Never mind that, it's going to be cycling the rest of the nutrients in the system. The other one that besides adding the compost, feed pellets. If you're going out and using something like lucerne pellets, great source of all the nutrients, plus all of the nutrition in there is carbon based. So this way the microbes in the soil are going to be able to use it. It's going to be way more efficient than using a salt or a synthetic fertilizer. And the other thing is, and once again, I've traveled from Geraldton down to Esperance, and we need to have more tap-rooted plants in our system. We need to get them going. And so, looking at these, making a bit of a list of what we could and should be adding. So, compost, the Johnson Sioux system works really well using compost extracts, using proper grazing methods. So this way we're getting those roots down deeper of our plants. Those feed pellets, using green manures, multi-species blends, and then responsible manure applications. Insects, the garbage men of nature. As long as we keep our bricks over 12, we don't have chewing bugs or sucking bugs in our system. So that's the thing we want to be looking at is keeping that sugar level in those plants as high as we can. And once again, we have to keep that system going. Properly incorporating livestock. So most of our soils are built on forage plants and grazing animals. And in Australia, okay, so fire. In Canada, we had lots of fires too. And but on the flip side, using these, using livestock, in a lot of cases, it's also destroyed a lot of soil. So when we look at the Mesopotamia, we look at Greece, we look at any of these large empires that failed, it all goes back to the overgrazing of our land, and it's destroying our soil structure. And these empires kept having to grow in order to keep producing enough food. So one of the books I like recommending is Dirt: The Erosion of Civilization by David Montgomery. Great read, a little depressing because the stuff that he talks about we're repeating now. So when we're incorporating these livestock, we have to remember the soil drives the soil microbes, which then has a feedback loop with plants, and we're using the animals to manage our plants. And at the end of the day, when the animals die, they go back to the soil. So we have this loop, and we need to use those grazing animals to manage the forage and not the other way around. We don't want to always take that grass right down to the ground as many times through the year. If it is for the fire control, absolutely. But when we start talking about that growing plant, let's keep those things going as and capturing as much sunlight, creating some photosynthate as much as we can in our system. And when we do that, we really start cycling nutrients, getting them from down deep in the soil profile and putting them back on top. And so one of the uh, visuals you can see is this grazing half and leaving half. And this is in the growing season. When it starts going dormant, then we can graze it down. We can, do some management there. We still, try and keep as much soil armor as we can, but we want to be able to store that water and protect our soils. And that's where there's once again when Andrea was out in Australia, it's what he was dealing with is very similar to what conditions are like in Western Australia. One of the things when Jay Fuhr from the Menniken Farms in North Dakota, one of the things he did is he went out and he went through his cover crops, and he picked the plant, balanced it on his finger, and that's 50, the top half, the bottom half of the plant. So he broke it in half. He did the feed test on both, and when you look at the feed test of what is on the top and what's on the bottom, all the nutrition is in the top half of the plant. In most cases, the bottom part of the plant is lower protein, lower relative feed value, lower TDN, and it also is higher in nitrates and it's higher in lignin. There's more anti-feed benefits in the bottom half of the plant. So the more you make your cows and sheep eat the bottom half of the plant, it's actually costing you more money than if you're going out and you're just taking that best part of the plant. So using that electric fence is a really good tool in order to keep them moving. So if you're looking at if you don't have enough feed, you don't have the opportunity to do some of these principles, this is where the cover cropping can be a really good friend. So whether it's yourself or you talk to your neighbors, seeding down that cover crop, it's going to give your perennial paddocks a chance to rest, and especially when they are about to go dormant. So if you rest them before they go dormant, they're going to have bigger reserves in their roots, so that this way, when the next season, when they're going to start growing, they can jump up and get going. And by doing that, that's going to give your perennials a lot more resilience. The other thing is, okay, so having the full season cover crop growing during that season, it gives you that opportunity for emergency fodder. So if it is a dry year, if there's whatever happens, some failure, you have that extra grazing or stored feed that you can then utilize in the future. And so if you do have a neighbor that is a grain farmer, or if you have a friend, for me, I had animals on my farm for 22 years and I never owned an animal. I was working with a neighbor that did own animals. So partnering with a grazier, a great way to help diversify someone's system and diversify the income. And one of the great quotes, if you want to do some reading of once again a forward-thinking person, Sir Albert Howard wrote this in the 1920s. And never does nature separate the animal and vegetable worlds. And we've done this in agriculture, and that is one of the problems that we have seen. How are we doing for time?
Time.
Jordan, are you there?
We're running a little bit tight on time. Could you go through a little bit quickly and then we can ask some questions?
Pardon me?
Is my speaker working? Could we go through?
You're on. I missed the first part of the sentence.
Oh, could we go through the last couple of slides a little bit quickly and then we can ask some questions?
Yeah, I could wrap it up like I was. The next section is on producing cover, or like designing cover crops, and
I think that'll be good to cover.
okay, I'll go quick.
Can ask some questions. Thank you.
Yeah. Okay, so designing cover crops. So when we go through, once again, goal setting is really important because we need to know what we want to be producing. And one of the things that I found was, the more diversity we add, the better. So my definition of cover cropping is growing plants to protect and improve the soil. I don't want to get more detailed than that because then we pigeonhole ourselves of what we can and cannot do. We need to be goal oriented. We need to do forward planning. And that's the reason why I want to be coming in February, so that this way we can be planning our March or April plantings, so we can get the best bang of the buck out of the whole program because we have that thought process in place. So when we're designing the blends, we need to build synergies. We want to avoid contamination and competition. Looking at what weeds are growing is really important for me because I get to know where your fungal bacterial ratio is. I get to know if you have compaction issues. I get to know what I understand what these weeds are telling me. It also tells me where your fungal bacterial ratio is, and with discussions, what direction do you want to move it? Do we want to have more native species popping up? Do we want to start growing more shrubs? Those type of questions. So, these fodder blends, goals. What type of livestock, time of seeding, when are you grazing or cutting it? What feed constraints? When do you have a feed constraint? When's your window? What soil problems do you have? How do you manage it? Those are all going to I'm going to be taking into account when we're putting these blends together. And a lot of the blends that I've been seeing in WA, when people tell me they have lots of diversity because they have 5 ryegrasses and 2 legumes, 2 clovers, that's 2 functional plant groups. We need more diversity. So growing these full season cover crops, we wanted them to grow the full season. We'll do some grazing, we'll cut them, we'll do whatever we need to do to harvest them. And these are the things we can be doing. We have that flexibility in the system to make them work for us. And we get that by having diversity. And the reason why we want this diversity is, number one, is have this legacy effect. So Dr. Christine Jones, when she was down in the Margaret River area, she was talking about, each seed has 9 billion microbes in it. And that seed has its own soil microbiome. And when we start throwing more and more species in there, we get more and more diversity of those microbiomes, which then start inhabiting in our soils. We get more resilient soils. And so we can get a lot of built-in system resilience by having more and more unique microbes in our system. And this is just down the road or up the road from you over at Haggerty's. 95% sand, 1% organic matter, and when you can have a rhizo sheath like this, that's when things are happening. So that when we have this rhizo sheath and you're seeding into it, and the plant dies and you seed into it again, the new roots are going to follow the path where the old roots were. And when they are following the old path routes, that's where the rhizosheath is. So now that new plant is going to be able to use the old microbiome of these plants that were growing in that soil in the past, as long as we're not doing too much tillage and destroying those microbiomes in that soil. When we have these dissimilar microbiomes, when we're growing them, we get more and more root interaction, intermingling, we get more and more sharing. It's the plants that we then harvest have a better microbiome. When the animals eat it, they get a improved microbiome in their gut. They become healthy. It's a beautiful system that just builds on itself, and once again builds resilience. When we have a plant in a mix that has, say, some saline tolerance, that saline tolerance, if it is a genetic thing and a microbial thing, what that plant, that saline tolerant plant, when growing beside a plant that is less salt resistant, saline tolerant, it will be able to share that microbiome that may turn on genes that will help that non-saline plant become more saline tolerant, as crazy as that sounds. So that as we keep going and building, we become a lot more resilient in our system. And so that legacy effect is so important. And so this is where these functional plant groups is so important. The quorum sensing, that's the other one, that, having that ryegrass and clover. If you, once again, if you say you're growing ryegrass, all you do is tell me once. If you're growing 5, just say you're growing 5, because that's just one functional plant group. When we throw these other different functional plant groups in, all of a sudden this quorum sensing kicks in, and when that happens, then we start seeing some beautiful things happening in the soil, both in the plant production and our animal production. So setting goals, what do you want to address? That's the reason why I stressed that early on. What species do you have ecological function that are going to work in your system? When you're seeding it, how are you seeding it, how are you utilizing it? All those things are so important to drive the function of this system. And when we have it, it becomes easier and easier. So first of all, when we're designing blends, so I've created a spreadsheet that it helps design these blends and seeding rates. So what species do you have available? What is the cost of the seed? So we can put that into the spreadsheet, see the economics. What is a monoculture stand of that species for the seed density? What plant density are you aiming for? So you're really good soils, let's crank it up a little bit. If you're dry, let's cut it back. How many species are you using? That's going to indicate how many, what percentage of the monoculture rate we're going to be going with. Need that plant diversity. It's amazing when we get these different plants, how all of a sudden that system starts working, and how the animal response. So the seeding tools, we can have disc openers, that's going to give you the least disturbance. The tine openers, there's some more soil movement, but we have to pick the right opener for when we're going to be seeding with it. But maybe it is something that it's sod bound. We have to fluff it up. Broadcast seeding, that's your highest to establish. So you blow it on, you're hoping that it's going to rain, it's going to germinate and get going. So some of the other options out there, and this is a great thing of dealing with farmers, we're going to come up with a bunch of ideas, and it may not work for you, but okay, so how does it work? So this is Amish over in Northeast USA. They found a way to make it work. And if that's a little too old-fashioned for you, then using a 3-point spreader on your tractor is a great way of doing a broadcast if they're forecasting rain. And what I like about this system is that little spreader in front is your variable rate. So I'm not very high tech, but if you're going through a spot that has a different soil condition, so a little more saline, you can turn on the spreader in the front where you're going through the saline spot, have something a little more salt tolerant, and have your other blend being spread through those spots, which gives you a little more flexibility. There's a guy over in South Australia. This is, of course, for mice, but what a great way to put on a cover crop as you're seeding your cash crop. So once again, it's a one pass. You need something small seeded, not putting on very much, but it'd be a chance to go out and do a one pass seeding. Otherwise, because because dry, because broadcasting is a little higher risk. If you had a toolbar and once again some way to feed it, this is a great way of no disturbance and going straight into a stand. If you are going in and have access to a high clearance sprayer, putting on these little broadcast units on a sprayer boom, another great way of getting it done. Otherwise, there's a lot of planes out there. I've been talking to like guys like Brad Jones, where they're going out and broadcasting rodenticides. Well, guess what? You can go out and you can spread cover crop seed through planes, and just to get it out there. But at the end of the day, this is that spreadsheet that I was talking about, so that this way we can go in and really tweak what we're looking at. So, this is I figured out the kilograms per hectare we're going to put down, how many seeds per square meter we're getting, what is that of a pure stand of that species, what percent of the plant stand of this blend is going to be. So this way you can visualize how much of that plant is going to be represented by the species we're adding. The kilograms per hectare, I don't have anything in there, but this way it gives you that opportunity to put in what the seed cost is, to then calculate the cost per hectare on the type column. That's telling you what functional plant group, so warm season grass, warm season legume. So I have my code in there, tells you how much seed you need, and on the bottom, the dollars per hectare. So that this way we can really go through and look at the economics and see how that works. So when you start measuring change, some of the things we're going to be looking at, when we're dealing with the management, we have to think about when we do management, how's that going to affect our bacteria? How's it going to affect our fungi, our nematodes, our protozoa, good and bad? How is our management system? What is it doing to our soils? And how do we change to make it better? When we're measuring the change, what are we looking for? I like looking at the soil aggregate stability, which is a simple test. We can look at the micro aggregate stability, our water infiltration. If we had a penetrometer, we'd look for compaction. We can send it away for a lab for soil organic carbon to see where we're at that way. We can send it into a lab and find out what our fungal to bacteria ratio is to get an idea of where microbial population composition's at. We can check our respiration rates. We can get our chemistry tests. We can test our C to N ratios. There's a bunch of ways we can do it. But as we go through, we want to look at, get out there with a shovel, look at what our structure is, what our color looks like of our soil. How does it smell? The depth of our horizons in the soil, and look at what our roots are doing. And so there's a couple demonstrations. So this is going to be a rainfall simulator video that we have, and we'll do this as a quick run.
It's raining, it's pouring, it's pouring, it's pouring.
Are you there, Jordan?
So you can
there we go.
see what happened with us.
So this is a rainfall simulator, relatively simple. They took a core of soil out of the soil, and so there's a perennial forage. There is short-term forage. There's some crop ground, and then there is some land with very poor cover. And what we've done is they have a walk container over top with a bunch of holes in it. So we added water to it, so then it has the same effect as rain. And so we can see the on the right-hand side, the water is landing on the soil surface and running across. And in the bucket in front, that is the runoff. There we go. If on the far left side, you don't see any water in the bucket in front, because the water is percolating into the soil and going down and ending up in the bucket underneath. And so it's a relatively easy demonstration, so we can see where the water is flowing. So if it's running across the top and you can see that beautiful brown color on the right hand side, that's where your carbon's going. That's where your nutrients are going. It's costing you money when that happens. Whereas if we can have it coming through the soil and getting stored in the soil, that's a huge win for us. Okay, so now the next video. If anybody's interested in seeing the whole video, just get a hold of us and we can get you a copy of it. I have no problem sharing it.
Okay, here's a slick test that we're going to do. On the left
so
is
the
going
other
to
one that we
be
have
from a field
that's really easy is a slake test. And what you'll do is you'll get a jar of water. You'll make yourself a bit of a mesh, wire mesh, and you'll get a soil colloid that you'll dry down completely. So let it put in the ute and let it dry down completely. When it dries down, then you're going to
been
put
perennial
it into water,
ryegrass, and on the right is
a
cultivated strip that receives lots of tillage. So we will put the soil samples in, and we'll see what happens.
And so I've grabbed 2 soil samples. The one
so
on the
you can
left
see the
is
one on the right
from
is
a
slated
grassland
quite heavily, not a lot of fungal growth in it, very highly bacterial soil. The one on the left has been
our farm yard
reduced
where we
tillage,
drive
reduced nitrogen.
so there's guess what?
We
There's
just have a more stable
there.
system.
We did a lot of tillage, but it's a great demonstration to be able to show how our management of our soils, and we can have
quite a bit of bubbles coming out of the left one.
That soil fungi populations in our soil, how we can make stable soil aggregates and create healthy soils. So which one would you want to farm? The left one or the right one? The left one is stable. It's going to be resilient against erosion. It's going to have water infiltration. You're going to have good rooting. You're going to have your system's going to be working. So I think that is just about it for the presentation. On the last few slides, I have some resources. So if anybody's interested in reading or doing some more YouTubes,